Hello everyone. In this video, we are talking about determinants and Cramer's rule, section 10.3. We start from the 2x2 determinant. I'm going to explain the definition here. Let's say we have a 2x2 square matrix. We have the definition for matrix in previous video, right? Let's say we have 1, 2, 3, 4. Those are the 4 entries in this 2x2 square matrix. I just randomly select those entries. They could be any other numbers. Because this matrix is a square matrix, means the number of rows and the number of columns are equal to each other. We are able to define the determinant of this matrix. If we let the matrix be A, then we are able to define the determinant of A. That's the notation, or determinant of A. By the way, this is not an absolute value. Looks like absolute value notation, but it's very different. We put two vertical bars on each side of the matrix to frame the matrix. Then we would have the determinant of the matrix. So that's the concept of the determinant of a square matrix on surface. But the real definition is more complicated. By the actual definition for a determinant, we are able to evaluate the determinant. The actual definition actually could be used to evaluate a determinant, but we don't have to know that. All we need to know is if we have a determinant, then the determinant is a value, is a specific value. That is also the difference between a matrix and its determinant. So let's see those two things. This is a matrix A, right? It is just a rectangular array of numbers. It's just a bunch of numbers. That's matrix. But for determinant has its own operation in the definition. But we don't really learn the definition here. But the definition, the operation, it is a value. It is a specific number. So very important difference between a matrix and a determinant. Matrix doesn't have to be square. As I said, the number of rows could be bigger than the number of columns, or the number of rows could be smaller than the number of columns, or they could be equal. And only square matrix could have determinant. And the notation for determinant, we use the two vertical bars to frame the square matrix to have the determinant. And in essence, this is just a bunch of numbers, a rectangular array of numbers, and this is one value, one specific value. Depends on the entries in the determinant. So I'm going to show you in example 1, how do we evaluate a 2x2 determinant. In example 2, how do we evaluate a 3x3 determinant. Very important, okay? One thing we need to know, this direction, this is a diagonal, right? That is the main diagonal. That is the main diagonal. And this is the vice diagonal. We have that in the D quiz, so you would have to know the concept. The green direction, that's the main diagonal, MAIN. And the other direction, that is the vice diagonal. Okay, so how many entries in the main diagonal? 2 entries, right? 1 and 4. We're going to take the product of them, 1 times 4. And how many entries in the vice diagonal? 2 numbers, right? We multiply them together. What do we have? 2 times 3, 6, right? For the main diagonal, we're going to keep the positive. For the vice diagonal, we're going to put a negative sign in front of it. then we would have 1 times 4, which is 4, minus 2 times 3, which is 6. The value of the 2 by 2 determinant is negative 2. Is that understandable? Actually, let me also do example 2 on the notes. In my notes, I have a problem. To evaluate this 2 by 2 determinants, the 4 entries are x cubed, negative x squared, x squared, x. So we're going to apply the rule we have just learned to evaluate that 2 by 2 determinant. Firstly, we need to find the main diagonal, green. We're going to keep the color. Green would be the main diagonal, and the pink would be the vice diagonal. Multiply the 2 entries on the main diagonal, x times x cubed times x. And multiply the 2 entries in the vice diagonal. That would be x squared times negative x squared, right? Remember, main diagonal always positive. The product from the vice diagonal always negative. Then we have x cubed times x, x to the power 4th. Negative negative gives us positive, right? Positive x squared times x squared, that is x 4th as well. So we have twice of x to the power 4th. I believe after those 2 problems, you should grasp the method of solving or evaluating a 2 by 2 determinant. What if we have a 3 by 3 determinant? Let's look at example 3. I'm going to apply 2 methods. I'm going to apply 2 methods to evaluate the determinant of A. So determinant of A is this determinant. It has 3 rows, 3 columns. It's 3 by 3 determinant. 0, -3, 1, 2, 0, 5. -1, 3, 2. The first method is kind of like a tricky. I'm taking column 1 and column 2 and write the 2 columns to the right of the determinant. 0, 2, -1. -3, 0, 3. Okay? And then I would have 3 main diagonals. This one, this one, and this one. And 3 vice diagonals. They are this one, this one, and this one. Now, this is a good method. Many students, they like this method. All right, so let's look at the 3 main diagonal. We have 3 entries on the first green line, right? 0 times 0 times 0. What is that? 0. Okay. And in the second green diagonal, we have 3 entries as well. They are -3, -3, 5, and -1. We're going to multiply them together. What do you have? -3 times 5 times -1. Do we have a positive or negative? Positive. Positive 15, right? Okay, in the third green line, we have 1, 2, 3, 3 entries. Multiply them together. What do we have? We have 6. Let's see the pink lines. The first pink line, we have 3 entries. 1, 0, -1. The product of the 3 entries is 0. Second pink line, 0, 5, 3. Multiply the 3 entries together, we get a 0 again. Third pink line, we have -3, 2, 2. Multiply them together, what do we have? -12, right? 2 times 2 is 4. 4 times 3 is 12. But remember, for the main diagonal, positive, positive, positive. For the vice diagonal, the other direction, negative, negative, negative. Be very careful. Then let's see what we have. 0 plus 15 plus 6 minus -12, that is plus 12. So 21 10.3. Do you like this method? Many students, they like this method. I am going to expand the determinant from row 2. How do I do that? So look at this number 2, this entry. It is A21. The subscripts 21 means the entry is in row 2, column 1. Okay, so by its cofactor would be capital letter A sub 21. I am going cofactor. What is the cofactor of the in a moment? Okay, yeah. And let's keep column 2. So we use A sub 22, A22 to represent that entry, A22. Use sub 23, row 2, column 3, row A sub 23 to represent the entry 5, and then multiply its corresponding cofactor, capital letter 23. Okay, so what is a cofactor? Cofactor is a sign, -1 to the power of 2 plus 1. What is 2? 2 is the number of rows, the row number of the entry. 1 is the column number of the entry, right? So I added the two subscripts together as the exponent of -1, and multiply by big M to 1. What is big M to 1? Big M to 1 is the minor. For the purpose of the day quiz, you need to know what is minor. Don't worry, I'm going to explain what is minor, okay? So now you need to see the connection and differentiation difference between cofactor and minor. Cofactor is a sign multiplied by minor. How do we determine the sign? The sign is always -1 to a power, -1 to the power of a number, and that number always the sum of the two subscripts. If you repeat this part, you should get it. I think I made it pretty clear already. So second entry, A22. The cofactor big A22 would be equal to -1 to the power of 2 plus 2 multiplied by its minor, big M22, plus A23, and the cofactor, capital letter A sub 23, equals -1 to the power of 2 plus 3 multiplied by big M 2 sub 3. Big M sub 23. Big M sub 23 is the minor of the entry 5. Okay, finally, let me explain what is the minor, okay? A sub 21, A21, that is 2, right? Copy it here. And then we copy the sign, -1 to the power of 2 plus 1. What is the minor? What is the minor of the entry 2? What is the minor of the entry 2? This is the entry 2, right? What is the minor? The minor of that entry is a 2 by 2 determinant. You cross out row 2 and column 1. You cross out the row and a column that the 2 locates. And the rest of the entries, you have 4 entries left, right? -3, 1, 3, 2. Keep the order of the 4 entries. You have a 2 by 2 determinant. -3, 1, 3, 2. This 2 by 2 matrix, 2 by 2 determinant. This 2 by 2 determinant is the minor of the entry 2. Is that clear? Okay, let's keep going. Plus, I'm using blue, right? A sub 22, second entry in row 2, that's 0. 0 times -1 to the power of 2 times 2 plus 2. Multiplied by is minor. What is the minor? Do you remember how do we find the minor? This time we cross out row 2 and column 2. The rest of the entry would give us a 2 by 2 determinant. That is 0, 1, -1, 2. Right? That's the minor. That's the minor of 0, entry 0, plus entry 5 times the sign -1 to the power of 2 plus 3, multiplied by the minor of entry 5. You cross out row 2 and column 3. The rest of the entries gives you a 2 by 2 determinant. 0, -3, -1, 3. So I think you should be clear now what is minor. Minor multiplied by a sign, that is a cofactor. How do you determine the exponent on the shoulder of -1? I have explained earlier. So let's see how do we evaluate this. This is negative, right? 2 plus 1 is 3. Odd number, so it's -2. And how do we evaluate this 2 by 2 determinant? I showed you in example 1 and 2. So we have -3 times 2, -6, minus 3. So the reason we won't pick a row or column with as many zeros as possible, that's the benefit. We don't really have to worry about this part at all, because 0 times anything is just a 0. So you see what I'm saying? So we don't have to worry about this part anymore. And 2 plus 3 is 5. -1 to the power of 5 is negative, so we have -5 here. Multiplied by the value of this 2 by 2 determinant. 0 times 3 is 0, minus -3 times -1, which is a positive 3. Let's see, what do we have? -2, this is a -9. And this is -5 times -3. Negative, positive, 18, plus 15, 33. We got the same result with earlier, the first method. Okay, so you can choose either method that you prefer. For 3 by 3 determinant, I would believe the first method is better. But if the determinant has a higher order, like a 4 by 4 or 5 by 5, or even 6 by 6 and so on, then the second method, by using the cofactor minor to expand the determinant from one row or one column, would be better. Because this method only applies to the 3 by 3 determinant. And this method only applies to 1 by 1, 2 by 2, 2 by 2 determinant. Okay, so we're going to continue in next video. This is the first part of 10.3.